This is Unit 5 Progress Check Part B. Number 1 and number 2 both are calculator questions. So number 1, the second derivative of the function f is given by that function right there. At what value of x in the interval -4 to 3 does the graph have a point of inflection? So a point of inflection compared to the second derivative, what we can see there is that's a point of inflection is when a graph changes from concave up to concave down. Looking at the second derivative, we know if the second derivative is positive or greater than 0, we know it's concave up. Remember, greater than 0, if we look at the graph of the second derivative, that means it will be above the x-axis. And concave down is when it's less than 0. That's when it's below the x-axis. Oh, below the x-axis, which means a point of inflection is when it crosses 0 and it switches from positive to negative. So it can't just bounce off the x-axis. It has to cross through the x-axis. So a point of inflection is when the second derivative crosses through the x-axis. All right, so what we can do is we can graph this function. And again, we're only looking from -4 to 3, so I have a calculator over here. This top function is the function that we're referring to, x squared times the cosine of x squared plus 2x over 6. I know this calculator looks different than others. We do want to make sure it's in radians, so make sure your calculator is in radians. I'm going to take this one off for now, so that will just graph the top one. So I'm going to hit graph. That looks like a mess. Let's go ahead and zoom. Let's just go to our standard graph. This I can kind of zoom in on my own here. So we want to look between -4 and 3. And so between -4 and 3, we're looking for where the second derivative crosses through the x-axis. It looks like it's just above 2. It crosses through the x-axis. And that is the only place it crosses through. At 0, it just changes direction on the x-axis. So it's just to that number that's a little above 2, which looks like, looking at our answers, is this 2.229. If we had to, you could find that exact value on your calculator. On this calculator, I can just slide this to where I want it, and it snaps to it, and there it is, 2.2289. All right, number 2. We'll bring this back in a second. The second derivative of the function f is given by second derivative of x equals sine of x squared over 8 minus 2 cosine of x. The function f has many critical points, 2 of which are x equals 0 and x equals 6.949, which the following statement is true. All right, so this is going to go back to the idea that we talked about in the first question. We know if something is concave up, it's going to have a minimum. So since x equals 0 and x equals 6.949 are critical points, we're looking for whether it's positive, whether the second derivative is positive or negative at these points. If the second derivative is positive, it's concave up, which means we will have a minimum. If the second derivative is negative, or below the x-axis, at the points we're talking about, it will be concave down, which means we will have a maximum. So let's take a look at that graph. So looks like we're ready to go here. So I'm going to hit graph. We actually need to look at the points 0 and 6.94. So make sure we're seeing those points. So when x is 0, looking at our graph, when x is 0, the second derivative is -2, which the important part is it's negative. So the second derivative is negative at 0. So at 0, let's write it like this. The second derivative at 0 is negative, so it's concave down. Concave down, which means it's a maximum. And what about at 6.949? It's also negative, 6.949. It's also negative, so it's concave down. Sorry, I wrote that wrong. Second derivative at 6.949 is a negative, so also concave down. So both of those are maximum points. So D. All right, that's all we have for the calculator for now. Number 3, let f be a function given by f of x equals 2x cubed plus 3x squared plus 1. What is the absolute maximum for f on the closed interval of -3 to 1? All right, so what we want to do here, we want to find the absolute maximum. We know we can find an absolute maximum because this is continuous. So by the extreme value theorem, we can find an absolute maximum. The absolute maximum will either occur at a critical number or at an endpoint. So first of all, we want to find any critical numbers. So we're going to find when the derivative is equal to 0. So we'll take the derivative. We get 6x squared plus 6x. So we want to set that equal to 0. So we get 0 equals x squared plus 1 if we divide both sides. Sorry, x squared plus x if we divide both sides by 6. And x equals 0 or -1. And so we want to do our candidates test here. We want those two critical numbers and we want the end point. So let's put them in order here. -3 is the left side of our interval, and then we have -1, 0, and 1. We're going to put each of those numbers into our original function to find out what the absolute maximum is. This is not a calculator question, so we have to go ahead and plug in to the original function. So putting -3 in, so this is 2 times -3 cubed. And depending on your arithmetic skill, you can do this quicker. You can write all the work or just think through it. So -3 cubed, that's -27 times 2 is -54. Middle term, -3 squared is 9 times 3 is 27, plus 1. And so that's going to be none of these numbers in our choice. It's going to be negative something. We can find it. It's negative 26, so -26. So not that. Plugging in -1. So -1, a little easier. So putting -1 in there gives us -2. Plugging -1 into 3x squared is 3 plus 1. So that's 4 minus 2 is 2. Putting 0 in, that's nice and easy. If you put 0 in, both of those are 0, so it's 1. And putting 1 in gives us 2 plus 3 plus 1, if I can see these signs right, which is 6. And so looks like our largest one is 6 here. So maximum at x equals 6.